Hello, and welcome to our webinar. My name is Pat Schleisman, and I am the Engineered Wood Specialist in the Southeast Territory for the Market Access and Development Division of APA. I will serve as moderator for this session. Our main speaker today will be Jacqueline Miller. Our topic today is titled APA and IRC Simplified Bracing Methods. Before we start today's webinar, I need to cover some housekeeping details. This presentation will last about 55 minutes. Handouts of the slides can be found in the control panel on your screen. To ensure that everyone can hear the webinar clearly, we have muted all participants. While we are bookending the discussion with our cameras on, we will be turning them off during the session to maximize the connectivity of the webinar. During the presentation, we encourage you to submit questions by typing them into the questions pane on the control panel on your screen. We will answer some questions in the chat box, and we will answer some in a Q&A at the end of the session as time permits. A recording of today's program will be posted on our website, www.apawood.org, in about a week to give a further opportunity to review content or share with others who were unable to attend today's session. APA has long served as the voice of the engineered wood industry. Founded in 1933 as the Douglas Fir Plywood Association, it later became known as the American Plywood Association. About 30 years ago, the organization was renamed APA, the Engineered Wood Association, to better reflect the wide range of engineered wood products manufactured by its members. Today, APA is a nonprofit trade association representing manufacturers of a variety of structural engineered wood products used in design and construction. In addition to product testing and quality verification, APA conducts research to enhance engineered wood product design and performance, as well as the systems in which these products are used. APA also educates designers, specifiers, and other stakeholders on the proper use and application of these products. One of the most widely adopted systems developed and standardized by APA is the wood portal frame, commonly used in residential construction across the United States. First, a little helpful information about APA. APA has 4 divisions. The Market Communications Division maintains over 650 free downloadable documents, as well as the APA website and our social media. The Technical Services Division has a 42,000 square foot research center, which is a state-of-the-art laboratory staffed by experienced engineers, scientists, and engineering technicians. That staff evaluates market needs and opportunities that best serve the industry. The Quality Services Division provides certification to ensure that APA manufacturers conform to APA product standards and policies. As part of the certification process, APA member mills are subject to ongoing manufacturing audits and inspections to ensure conformance to the product standard. When you inspect construction projects, you will notice the APA trademark printed on the wood. This is given to the manufacturers that satisfy the product performance standards. Lastly, the field services team is now under Market Access and Development, MAD, which consists of engineered wood specialists located throughout North America. The engineered wood specialists provide information and recommendations to construction and design professionals like yourselves. We focus most of our time on residential construction, but support engineered wood products in all markets. This division is also home to APA's help desk, where hundreds of calls are answered monthly from across the country. I'd also like to note that today's webinar is approved for continuing education credits, including AIA and ICC. About an hour after the conclusion of the webinar, an email will be sent to each attendee. It will include a link where you can get customized certificates of completion. The information provided in this webinar is based on APA's research and field experience, but no warranties, express or implied, are made. APA and its members are not liable for any damages resulting from the use of this information. Users should consult local regulations or a design professional to ensure compliance with relevant codes and standards. APA does not control workmanship, quality, or usage conditions, so it cannot guarantee product performance or design outcomes. The content is copyrighted, and reproduction or use for AI training requires written permission from APA. Your feedback is important to us. You'll see a QR code on the screen. Please take a moment to point your smartphone camera at it. A link will pop up taking you to a short survey about this session. You're welcome to scan the code now and complete the survey at your convenience. We'll also display the QR code near the end of the session. Now I'd like to introduce today's presenter, Jacqueline Miller, Engineered Wood Specialist for the Midwest region. In her role, Jacqueline supports designers, building officials, and builders by providing guidance on construction and design using engineered wood products manufactured by APA member companies. She is based in the Chicago area where she grew up. Jacqueline is a graduate of the Rose Holman Institute of Technology, and she is currently pursuing her MBA at Utah State University. Prior to joining APA, she worked for 4 years as a structural design engineer on a variety of residential and commercial projects utilizing engineered wood systems. Outside of work, she enjoys hiking with her husband and her dog. For those just joining us, welcome to our webinar titled APA and IRC Simplified Bracing Methods. And now I'll turn the program over to our speaker, Jacqueline Miller.
Thank you, Pat, and thank you everyone for attending today. We're about to dive into our content, so to better facilitate the presentation, Pat and I will now be turning off our cameras. I'd like to go over our learning objectives for today. I'm assuming you all read these in preparation, so I'm going to summarize. Essentially, we are going to be looking at the APA Simplified and the IRC Simplified wall bracing methods. We're going to discuss when you can use them, how you would use them, and the advantages they provide. Before we can talk about wall bracing, we need to talk about why we need wall bracing. There are two main types of lateral load that we account for: wind and earthquake or seismic loading. Some people have a hard time visualizing how these loads would affect the house, so I like to give analogies from the real world. For wind, let's say you're leaving your favorite hardware store with a 4x8 sheet of wood structural panel, certified by APA, of course. The panel is only relevant to the analogy because it increases your surface area, so you feel more wind. Then, as you're standing there, there's a huge gust of wind. What would you do? You would probably bend your knees, maybe lean forward a little bit, use your muscles to try not to fall over. It's the same thing that happens to a house. The lateral load resisting system, including braced wall panels and anchors, is the muscles of the house. On the right, we have seismic loading. Now picture yourself on crowded public transportation where there isn't room to sit. It could be a bus, a subway, the monorail at Disney, whatever you've used. When you slow down to stop, what do? You hold on to something, bend your knees, or you lean the other direction. You resist the ground motion with your muscles. A house does the same thing when subjected to the ground moving from seismic load. The lateral load resisting system comes into action to stop the house from falling over. To see the lateral load path through the house, we've broken it down into 5 steps. On the left, you can see wind loading, and on the right, you can see earthquake loading. Let's walk through the steps in the load path. They're similar in both cases, which is why the forces get grouped together. The load will affect one wall and then be transferred through the connections into the roof or a floor, and then it will be transferred to the perpendicular wall, again through the connections, and finally the perpendicular wall will take the load down to the foundation. If we look at these lateral loads in plan view, we can see the resistance, which will be provided by the wall bracing, is on the perpendicular wall to where the load acts. The length and width dimensions make a difference as the dimensions of the building change. A longer load wall generates a higher overall force, meaning more resistance is needed on the resistance wall. The load and resistance walls can easily be flipped because wind blows in all directions and the earth moves in all directions during an earthquake. If the length and width are to scale, resisting the load in this direction will generally be easier than the last slide because the load wall is shorter, meaning the overall forces are smaller, and the resistance walls are longer, which means there is more space for wall bracing while maintaining the same amount of openings. Looking at the resistance walls, we need a braced wall panel to transfer the load all the way to the foundation to have a complete load path as required by code. Note the applicable code section R301.1 shown on the right. The APA and IRC Simplified wall bracing methods are great ways to ensure a complete lateral load path with minimal confusion. Within braced wall panels, there are a lot of different options in the code. We will turn to the APA laboratory to compare the strength of 4 of these methods. These concepts will be key to later parts in this presentation. So here are the results from full wall bracing tests published in APA Full-Scale 3D Wall Bracing Tests, Form T 2007-73. If you would like to go read the full report, it's available for download on our website. The base case tested was intermittent wood structural panels. The lowest strength found was from diagonal wall bracing, which produced only 31% of the load resistance of the intermittent wood structural panels. Our third tested assembly was continuously sheathed wood structural panels, which provided 88% more load resistance than the base case. Finally, our fourth case is a continuously sheathed portal frame assembly, which resists 174% more load than intermittent wood structural panels. These results showed APA the benefits of continuously sheathed wood structural panels and portal frame assemblies. We need to talk about what can go wrong. Why do we care about wall bracing and completing the load path? I'm going to show some quick examples of 3 lateral load failures: racking, base shear, and overturning. First, we're going to talk about racking failure. If you've seen other APA webinars before, you might recognize this picture. It is honestly one of the best racking pictures I think you can get, so it's hard to replace. This shows how the structure itself tilts to the side and you lose that 90-degree angle in the corner. The rectangular wall or openings become a parallelogram. This failure is due to wind pushing on the side of the building and the wall bracing having insufficient strength to resist it. In this case, you can see that no wall bracing was applied, so that explains how we got such a perfect racking failure. If we go back to our wind and seismic load analogies from a few slides ago, you can imagine leaving a hardware store and experiencing a big gust of wind, or being on public transportation with starting and stopping motion, but now your feet are stuck in concrete, so you tilt backwards. Then we've got a base shear failure. This house already doesn't look like it's in great shape, but I think it looks even worse when you realize the front of the house is not where the front of the foundation wall is. This is what happens when we don't have enough anchors to resist lateral force and properly connect the wall to the foundation. Today we will talk primarily about wall bracing designs, but the anchors to the foundation are equally important to complete the load path. To go back to our real-life analogies, this would be you trying to resist the wind or seismic load, but now you're on roller skates. So when that wind pushes against you or the train stops, you don't have any way to stop yourself from rolling away from your initial location. Our last failure mode is overturning. Overturning is hard to get a good picture of because typically if a house is flipped over, it means it's a pile of rubble, which still counts as quite a significant failure, but it makes it harder to see in a picture. These are 2 pretty good examples. Essentially, what would happen is the house stays together because of the wall bracing, but doesn't have enough weight or hold downs to stop it from tipping over. Going back to our analogies one more time, this scenario has you holding that sheet of wood structural panel in the wind, but you are absolutely rigid. You cannot bend in any way. So if the wind is strong enough, you will tip over. Now that we understand the importance of lateral load systems, let's begin with the origins of the two simplified wall bracing methods we are discussing today. In the case of the IRC Simplified method, it's pretty straightforward. There's a section in the International Residential Code, which I will refer to as the IRC, that describes this method. It is section 602.12. It's the final section of the wall bracing area of the code. To find the system report that describes the APA Simplified method, follow these simple steps. First, go to the APA website, apawood.org, and then click on Publications under the Resource Library tab. Then type in SR102 or Simplified Wall Bracing in the search bar and hit Enter. This is the screen that will pop up. Then the publication is available for free download. In order to download something from APA's catalog, you do need to register and create an account. It is easy to register and gives you access to APA's 650 plus publications. We will go over how to register at the end of this webinar if there is time. The next question to ask is, where does the APA Simplified method come from? It was developed based on testing in the APA laboratory. You can see on the left an example setup from one of those tests. The APA Simplified method came from combined knowledge of multiple tests and reports relating to continuous sheathing, nailing patterns, portal frames, and more. With the results of all this testing, the APA Simplified wall bracing method was derived. It is based in similar ideas as the IRC Simplified method, but takes advantage of the additional strength provided by continuously sheathed 7/16 inch performance category wood structural panel and tighter edge nailing when compared to the code minimum. Through testing, we learned that these minor adjustments could provide an increase in bracing capacity of 21% over the minimum code requirement. That is what allows the lower required wall bracing lengths in the APA Simplified method. You'll be able to see this difference as we look at the table and go through our example. Okay, so now that we are familiar with the basis of both the IRC and the APA Simplified methods and can find them, we're going to describe their requirements. Because they are simplified methods, they have specific requirements in order to use each method. We're going to start with the requirements that are for both the IRC Simplified and the APA Simplified method. Both methods require the structure to be less than 3 stories. They need an eave to ridge height that's less than 15 feet, and then the floors can only cantilever 24 inches or less. The final requirement that you can see on this page relates to wall height. For the IRC Simplified method, the maximum wall height is 10 feet. There is one minor change for the APA Simplified method requirements. The wall height can be up to 12 feet, so that is a little bit of a difference between the two methods. We have a few more requirements to use either the APA or the IRC Simplified method. The structure has to fall within seismic design category A, B, or C for a single-family home, or category A or B for a townhouse. Then, the structure must have an ultimate wind design speed of less than or equal to 130 miles per hour and be in wind exposure category B or C. In this case, you'll see I chose an example of somewhere in Iowa. We would look at these two maps found in the IRC, and we would see that this structure falls under the IRC Seismic Design Category A and an ultimate wind design speed of 105 miles per hour, close to the 110 mile per hour border. But either way, it falls within the requirements. Our final requirement for using either the APA Simplified or the IRC Simplified method is that there can be no cripple walls in a 3-story building. You'll see later in this presentation that there is an adjustment factor for cripple walls in a 1- or 2-story building, but no cripple walls are allowed in the 3-story buildings. Additionally, permanent wood foundations are not allowed in either the IRC or APA Simplified method. We will now be differentiating the IRC Simplified method. It has some additional specific requirements to show you. The first one is that the exterior walls must have ½ inch of gypsum board on the interior face. There is an exception to this requirement for portal frames, which we will discuss later in this presentation. And the second is that all horizontal panel joints in the wood structural panels should be blocked. Those are the two requirements specific to the IRC Simplified method. Now there are two APA Simplified method specific requirements that we're going to talk about. The first is that the sheathing on the lower stories, meaning the first story of a two-story home and the first and second story of a three-story home, have above the code minimum panel edge nailing. The panel edge nailing is 8D common nails at 4 inches on center. For reference, the code minimum edge nailing is 6D or 8D common nails at 6 inches on center. The intermediate fastening does not change from the code minimum nailing of 12 inches on center. In the APA Simplified method, the upper story also has the code minimum nailing requirement. The second requirement is that the home must be continuously sheathed with 7/16 inch performance category wood structural panels. There is no option for intermittent wall bracing in this method. The structure must be continuously sheathed so that it can take advantage of the extra strength provided from having continuously sheathed wall assemblies. Now that we know the requirements and we have checked our house to make sure that we can use this method, we will transition into the steps of this method. There are 3 steps, so it should be easy to remember and execute. Step 1, circumscribe a rectangle around the structure. Now that we see what that rectangle would look like, we then verify it fits within the requirements. Both the long and short side must be less than 60 feet, and the maximum ratio of the long side to the short side is 3:1. Once we have that rectangle, we're going to go into the appropriate table. The table has the following 3 inputs. First, you would enter the row of the appropriate design wind speed, then select the row for the appropriate story, and finally enter the row for the roof eave to ridge height. The 2 options available for roof eave to ridge height are 10 feet or 15 feet. For reference, in a 60-foot wide home, an eave to ridge height of 15 feet is a roof slope of 6 to 12. Here are the wall bracing tables and a sample plan. The IRC Simplified table is on the left and the APA Simplified table is on the right. They are set up very similarly, but they have different outputs. The IRC Simplified table is going to give you the number of bracing units, and the APA Simplified table is going to give you an overall length requirement. If you add up all the brace wall panel lengths, they must add up to that number or more. On this slide, I gave the example of the upper story in a 115 mile per hour wind design speed with an eave to ridge height of 10 feet. For the example plan dimensions, I chose one side of the rectangle being 30 feet and the other side being 50 feet. This meets our requirements because both sides are less than 60 feet and then the ratio of 50 to 30 is less than 3:1. This table will tell us the bracing for the long side by entering the length of the short side. The length of the short side is 30 feet, so the table says that we need 2 bracing units in the IRC Simplified method. I demonstrated that in red in the plan below. The APA table tells us that we need a total of 5 feet of bracing. This can be split through multiple brace wall panels as shown in the plan view below in red. For the bracing on the short side, you search for the length of the long side, which is 50 feet. It tells you we need 3 bracing units with the IRC Simplified method, or 7.5 feet of braced wall with the APA Simplified method. Those values are before adjustments. We will talk about adjusting these values in step 2. The braced wall panels are illustrated in the plan views below in blue. One of the things to watch in both the APA and the IRC Simplified tables are the footnotes. In the APA Simplified table, there's a footnote B that allows linear interpolation. We will revisit the IRC Simplified table footnotes in the next slide. There is one footnote for the IRC Simplified bracing table that is really important to consider. That is that there is no linear interpolation in this table. If your building length is 32 feet, the appropriate column is 40 feet. There's no interpolation. As discussed on the last slide, linear interpolation is allowed in Table 3 for the APA Simplified method. So if the building length is 32 feet, you could use a value between the 30-foot and the 40-foot columns in Table 3. We will demonstrate this later in the example. I would like to take a second to pause here and talk about why the length of the long side is going to affect the bracing on the short side, and the length of the short side is going to affect the bracing on the long side. If we circle back to one of the slides we talked about earlier in this presentation, it comes down to load path. The wind load on the long wall is going to get transferred up into the roof or the floor. The fancy engineering term for that is diaphragm. It is then going to go over to the perpendicular walls. The wind that is hitting the long wall is being transferred to the foundation and supported by the wall bracing on the short wall. That is why the tables are set up this way. I wanted to circle back on that point now that we've looked at the tables a little more closely. Now that we have completed step 1 to circumscribe the rectangle and find out the base length of the bracing required, we will be adjusting it. The APA and IRC simplified methods have some adjustment factors that are shared and some that are different. We are going to start with the ones that apply to both methods. Both of them have an exposure category adjustment factor. If you'll remember from our map, the structures can only be in wind exposure B or C. If it is exposure B, the adjustment factor is 1. If it's exposure C, I listed the adjustment factors on the slide. They vary for a 1, 2, and 3-story home. The second adjustment factor that applies to both methods is cripple walls and walkout basements. Essentially, you will treat this as a separate floor. So if you have a walkout basement like what is shown here, the walkout basement level is the first floor, and then the main level is going to be treated as the second floor when looking at your wall bracing requirements. This is one of the things we touched on earlier. I mentioned that you cannot have cripple walls in a 3-story structure. This adjustment factor helps explain why. If we're going to treat those cripple walls as a floor, and you have 3 floors above it, then you are essentially adding a 4th floor, which breaks our first requirement. That's a little background of how those things work together and the reasoning behind that limitation. The third adjustment factor applies only to the APA Simplified method. It is a wall height adjustment factor. If you'll remember, the IRC Simplified method only allows wall heights up to 10 feet. You'll notice that in the APA Simplified method, the adjustment factor for 10 feet is 1. In the APA Simplified method, walls can go up to 12 feet, but you will have to increase your wall bracing by 10%. Again, this adjustment factor is only available in the APA Simplified method. Next, we will transition to exceptions in the APA Simplified method. These are listed under the requirements, but have exceptions if you would like to remove them from the design. The first exception is included if horizontal panel joint blocking of the wood structural panels is omitted. If the horizontal braced wall panel joints are not blocked, the base value from Table 3 is adjusted by a factor of 2, which is a significant adjustment factor. The second exception is included if interior gypsum is omitted. If interior gypsum is omitted, the base value from Table 3 is increased by 40%. This can be isolated to only a single wall. For example, if the garage will not have interior gypsum, this adjustment factor could be applied to that wall, but not to the other 3 sides of the rectangle. Additionally, there is an exception for narrow bracing methods, which we will describe later in this presentation. The interior gypsum board is not required in those cases for both the APA Simplified and the IRC Simplified methods. You'll notice that these 2 exceptions are requirements in the IRC Simplified method. The IRC Simplified method requires blocking of horizontal panel joints and the inclusion of interior gypsum. The APA Simplified method provides those requirements as a default, but does have these exceptions. It adds a little bit of complication, but allows more freedom of choices. On to the final step. We have our base value, that was step 1, and then we have our adjustment factors, that was step 2. And now we are ready to lay out the panels. There are a couple things we are going to consider. A minimum braced wall panel width, a maximum spacing in between the braced wall panels, and then a maximum braced wall panel distance from the corner. The minimum panel width comes from a height to width ratio, and the maximum spacing and distance from the corner is required so the house is uniformly braced. There's technical engineering reasons behind these requirements as well, but we won't go into depth about those during this webinar. The overall goal is that the sum of the number of bracing units or length of panel, depending on which method you're using, is larger than the adjusted IRC or APA Simplified requirements. Let's review the layout requirements for the IRC Simplified method for intermittent panels first. There is a minimum length of wood structural panel, which is 4 feet. Then there is a spacing requirement of 20 feet maximum in between the panels. If you have a length of panel that is greater than 4 feet, you can take the actual length and then divide that by 4 feet. That will give you the number of equivalent bracing units. It is okay if you have a decimal number of bracing units. For example, if we had a 6-foot section, we would consider that 1.5 bracing units. And that's okay, because with the adjustment factors, the original base value might have a decimal as well. So don't worry about that. Bracing units do not have to be done in whole numbers. The final layout requirement is that the edge of the last braced wall panel must be within 12 feet of the corner. It can be at the corner, but as shown on this slide, if there is a window, then the first braced wall panel must start within 12 feet of the corner. The second option of layout requirements is still for the IRC Simplified method, but we have continuous sheathing. Even the parts of the wall that are not a braced wall panel are still going to be sheathed with wood structural panels. They are shown as lightly shaded on the slide. This is going to look relatively similar to the last one we walked through. The minimum length is 3 feet instead of 4 feet, so it's a little bit smaller. That is due to the increased strength of having a continuously sheathed wood structural panel wall. If you remember from our earlier slide, it's an 88% increase in strength. The spacing in between panels is still a maximum of 20 feet. And then if you have a longer section, you can take that length and divide by the 3 feet. So the 6-foot section we used as an example in our last slide would now count as 2 braced wall units. Finally, we have a 12-foot maximum distance to the corner, which is the same as the previous slide. This one is going to look fancy. It is just because there is a 3D layout requirement that we're going to talk about, so that's why it's relevant to look at the wall in a 3-dimensional view. We will start by covering the same content. The minimum braced wall panel length varies. We're going to look at that in a few slides. There's a table to determine the minimum length. There is a 20-foot maximum spacing between braced wall panels, just like in the IRC Simplified method. And if your wall section is longer than the minimum, you use the actual length. The APA method calculates the wall bracing requirement in feet. It doesn't have a quantity of bracing units like the IRC Simplified method, so we don't have to divide by anything. If the length of braced wall panel is greater than the minimum, that's how much it's worth towards the total. Similar to the IRC Simplified method, we have a 12-foot maximum distance from the corner to the first braced wall panel. I'm going to clear the screen so it doesn't get too cluttered. Okay, the 3D requirement pertains to wall offsets and bump-ins. There can be 4-foot maximum distance from the bump-ins to the edge of the circumscribed rectangle. Those are the requirements for the APA Simplified method. Looking at that offset requirement in plan view, you can see how it fits within the circumscribed rectangle. On the second floor, it's easy because it's already a rectangle. On the first floor, the circumscribed rectangle should include all bump outs and projections, unless they are going to be designed separately. We're going to talk about a way to design houses with multiple rectangles in a few slides. There should be a maximum of 4 feet from the edge of the rectangle to the braced wall panels. You can have further bump-ins as shown here in green, but they can't be braced wall panels. Keep in mind, any wall over 8 feet long should have a braced wall panel on it. So a short wall length to have a covered front porch is no problem, but it should be less than 8 feet. As promised, here is the minimum braced wall panel length table for the APA Simplified method. At the top you have portal frames, and we will discuss portal frames in just a second, but underneath that you have regular, continuously sheathed wood structural panels. The minimum length is dependent on the height of the opening next to the panel. There's an adjacent clear height opening from 60 inches to 120 inches, at different wall heights. For example, if we had an 8-foot wall height with less than 60-inch tall opening, the minimum length would be 24 inches or 2 feet. If we had the extreme opposite end of that, a 120-inch clear opening height with a 10-foot wall, the minimum length would be 36 inches or 3 feet. You may notice that compared to the IRC Simplified method, 3 feet is the minimum for continuously sheathed wood structural panel method, so those match. The APA Simplified method will let you utilize smaller lengths of panel depending on the wall and the opening height, so it's a little bit of an advantage. Another unique element to the APA Simplified method is partial credit. This only applies to 8-foot and 9-foot wall heights, but within those wall heights, narrower sections of wood structural panel are permitted. Table 2 shows the values of partial credit allowed in the APA Simplified method. It is not a 1-to-1 ratio. For example, a 20-inch panel next to a 72-inch tall opening provides 15 inches of wall bracing. This is an advantage of the method because it allows narrower sections of the wall to contribute to the total bracing, but not the full amount. It's a partial credit. Another way to utilize narrow sheathing panels is to use a portal frame. Portal frames are a topic that we can talk about for a much longer period of time than we have today. So we're going to conduct a brief overview of the 3 different types of portal frames and one of the publications available to you from APA about portal frame construction. If you'd like more information about portal frames, you can find it through our webinar, Code Compliant Portal Frames Built Right. The first type of portal frame is portal frame with hold downs. Portal frames with hold downs can be used for intermittent or continuously sheathed braced wall lines and can be used on a single-story structure or on the bottom of a 2-story structure. They cannot be used in 3-story houses. A unique element is that portal frames with hold downs require 2 3,500-pound hold downs, hence the name. The second type of portal frame is portal frames at garages. PFGs can be used in low seismic areas only and are only allowed next to garage door openings. It can be used on a single-story structure or on the bottom of a 2-story structure. The final portal frame is a continuously sheathed portal frame. This is the only portal frame method that can also be used on an upper floor of the structure. It also has the smallest width requirement. This method allows panels as narrow as 16 inches for an 8-foot header height. Taller header heights require wider walls. A common error we see occur is the strap location. The correct strap location is on the interior side of the wall next to the opening as shown in all of these figures. Portal frames are tested assemblies, so it is critical to build them as they are specified in code. If you need quick tips to avoid common errors like the one we just saw, APA has published a 2-sided builder tip that is written in Spanish and English. The document provides framing tips when fabricating portal frames. The builder tip, as well as several other portal frame related publications, can be downloaded for free from apawood.org. There are portal frame options in both the IRC Simplified and APA Simplified methods. In both methods, the portal frame segments do not require or have an adjustment factor for omitting interior gypsum sheathing. They were tested without interior gypsum, so they get to be an exception to the requirements of a typical braced wall panel. In our discussion, we're going to start with how to apply portal frames in the IRC Simplified method. There are 3 portal frame options: continuously sheathed portal frame that is equivalent to 3/4 of a bracing unit. We have a portal frame with hold downs that counts as 1 bracing unit, and a garage portal frame that counts as 3/4 of a bracing unit. Again, don't let the decimals scare you. It does not have to come out as a whole number. There are a few caveats to portal frames. For continuously sheathed portal frame, you are only allowed to have 4 of them in one braced wall line of the house. You can have more than 4 total over the whole house, they just can't all be on one wall. This limitation is removed in the 2021 and 2024 IRC, so depending on which code has been adopted, this limitation may be removed. For portal frames with hold downs and garages, I wanted to note that these are intermittent methods from the IRC code, but they can be used with continuously sheathed wood structural panels as well. Hopping back to the APA Simplified method, let's look at portal frames. There's only one portal frame option in the APA Simplified method. And because the APA method looks at wall lengths instead of bracing units, the continuously sheathed portal frame will be equivalent to 1.5 times the actual length of the panel. If we had a 2-foot continuously sheathed portal frame, it would count as 3 feet when we add up the lengths of all the braced wall panels. The other narrow bracing method is not a portal frame. It is the continuously sheathed wood structural panels adjacent to the garage method. It contributes its actual length with no multiplication factor. The same advisements come with continuously sheathed portal frames. There can only be 4 continuously sheathed portal frames in one line. For the CSG narrow bracing method, the wood structural panel does not have the details required in a portal frame. However, there are very limited locations where CSG can be used. It can only be used when the garage is supporting a gable end or roof load. It cannot be used with a second floor above the garage. Additionally, it can only be used on one wall of the garage. It should be used next to the garage door opening. The picture on the right is an example of where CSG braced wall panels could be used. There are some other requirements for CSG. Refer to Table 602.10.4 of the IRC and its footnotes for more information on this bracing method. Portal frames are a topic that frequently bring up questions during design and construction. Please remember that you are always welcome to reach out to your local engineered wood specialist with questions. Before we wrap up with a summary and an example, we have one last topic. A unique element of the APA Simplified bracing method is that you can have multiple rectangles. In the example shown on this slide, we are looking at an L-shaped building. In the normal APA Simplified method, you would not be able to circumscribe a rectangle around this lopsided building. It breaks the requirement of the longest dimension being larger than 60 foot. However, the APA Simplified method allows you to break this up into 2 rectangles. We would need to break up that 76-foot dimension, so I would suggest breaking up the L shape as shown here. Each rectangle must meet the initial requirements we described. We would go back to the beginning with each piece. Now, all the lengths are below 60 feet, but we would also compare the length to width ratio. 52 feet to 20 feet is 2.6 to 1. That is close to our 3 to 1 limit, but still falls below the threshold. Because the 52 feet and 20 feet ratio works, we know the 52 feet to 24 foot ratio works because it must be lower. We would just keep going through the 3 steps as we described with each rectangle. If you're going to use the multiple rectangle method, the procedure for all the separate walls is identical in a standalone building. In contrast, the common wall needs to have sufficient bracing for both rectangle A and rectangle B. Looking at this slide, you can see part of the wall for rectangle A is extended past rectangle B, so all of that bracing would go towards rectangle A. For the shared portion of the wall, we will split the bracing between the 2 rectangles in order to meet the spacing and overall length requirements. Here, I chose to provide more bracing for rectangle B because rectangle A has a large amount of bracing on the garage wall, so the real goal would be to meet the spacing requirements. If a common wall has both an interior and exterior portion, a combination of continuously sheathed wood structural panel and gypsum board sheathing can be used. If gypsum board sheathing is used on the interior portion, the total amount of bracing provided should be twice the length listed in Table 3. You can think of it as a 2 times adjustment factor. If the bracing requirement with the adjustment cannot be met on the common wall, continuously sheathed wood structural panel can be used on the interior walls to remove the doubled bracing requirement. In that case, you would use the original value found in Table 3 of the APA Simplified method with all the other adjustment factors, for example, wind exposure. We've made it to the end. Now our design is complete, so before we start our examples, let's summarize what the differences are for the APA and IRC Simplified methods so you can look at them side by side. The first one is that the minimum performance category of the sheathing is different. In the IRC Simplified method, the minimum is 3/8 inch performance category sheathing, and in the APA Simplified method, it's a minimum of 7/16 inch performance category sheathing. Then we can see the difference that the IRC Simplified method allows intermittent sheathing and the APA Simplified method does not. And then we see that the minimum lengths of the braced wall panels in the 2 methods are different, and there is a wall offset maximum in the APA method that does not exist in the IRC Simplified method. You thought we were done, but there are a couple more summaries. The maximum wall heights allowed in the two different methods are different. The APA Simplified method has additional exceptions for omitting wall blocking and omitting gypsum. In the IRC Simplified method, it is just a requirement. You cannot omit them. To complete our summary, there is a difference in the nail pattern requirements. The APA Simplified method has a nail spacing of 4 inches on center at the perimeter of panels for the first and second story of a 3-story and for the first story of a 2-story home. The IRC Simplified method uses the minimum code nailing everywhere. To clarify, in the IRC code, 6D common nails can be used with 3/8 inch performance category sheathing, and 8D common nails are required with 7/16 inch performance category sheathing. Now let's walk through an example. We're going to walk through the same example in both methods, and we're going to see how they differ. We will go through everything we just discussed, step 1, 2, and 3, with real numbers so you can get an idea of how to use each method. Okay, I chose a 2-story townhouse. It's 22 feet wide, 38 feet long, with a single garage door. This is a sample plan and elevation view. Before we enter the IRC or APA Simplified tables, we need to know some information about this townhouse. First, what is the ultimate design wind speed? In this example, I selected 115 miles per hour. The second piece of information is the story we are selecting. For this example, we will select the bottom of this 2-story townhouse. Finally, we need the roof eave to ridge height. It is 9 feet, which we will round up to 10 feet when we enter the tables. For the IRC Simplified method, let's walk through step 1. First, we would circumscribe the rectangle around the structure. Then, we would choose the ultimate wind design speed. Then, we would choose what story level and what roof eave to ridge height we have. We then look at the length of the short side and the long side, and we would find the number of bracing units in the table. So here's your answer. You'll remember that no linear interpolation is allowed. So even though the building dimension in the previous slide was 22 feet, that's going to round up to 30 feet because we don't get to take a weighted average. Step 2, we're going to look at our adjustment factors. Let's assume we're in exposure category B, which is an adjustment factor of 1. And that's it. The other adjustment factor would have to do with cripple walls or a walkout basement, but those don't apply to this townhouse. So we're done. It's that simple. Zooming through to step 3, for the example, we will look at the first floor front wall, because this is probably going to be our hardest one to design. With the short overall length and the number of openings, it's probably going to be our biggest challenge. And I believe in getting the worst one over with first. So we will start with the wall that is most likely to fail. Based on step 1 and 2, we would need 4 bracing units, right? Because we're taking the length of the long side to find our bracing on the short side. It's the perpendicular wall length that matters. Since our long side is 38 feet, we would round that up to 40 feet, and then if we went back to look at the table from the previous slide, the output was 4. That was our step 1 answer. Then we're going to multiply by the adjustment factor, which in this case is 1, and we're going to end up with 4 bracing units. The first thing we would do is make this section a portal frame because it's not long enough to be a full bracing unit. This will count as 3/4 of a bracing unit. Then we have 3-foot panels next to the garage, and that would count as 1 bracing unit each if we're using continuous sheathed wood structural panels. If we add all that up, it would total 2.75. So we have 2.75 units and we need 4 bracing units. That's definitely not meeting our requirements, so this would not comply. We're going to have to go back to the drawing board for how we meet our wall bracing requirements. We're going to hop over to the APA Simplified method and start back at step 1. We're going to circumscribe the rectangle, then we're going to choose our wind speed, our story level, and our eave to ridge height, and then put in the length of the short side and the long side, and come out with our final answer. We're going to be looking at the same front wall, so what we care about is the minimum required bracing for the short side, which is dependent on the length of the long side. I know I keep repeating that, but it is relevant and important that you pay attention to which side the wind is hitting and which side the wall bracing needs to be on. Our requirement is going to be 9.9 feet for that front wall. I'm tossing in step 1.5. I know that's unfair. I told you it was only 3 steps, and now I'm adding a half step, which feels like cheating, but the APA Simplified method allows linear interpolation. So we have 38 feet, not the full 40 feet. We can reduce that 9.9 feet to 9.4 feet. This simple linear interpolation is just drawing a line between the 2 points on the table and finding the point in between. If you need help with this step, Google and AI can probably do this for you relatively easily. Okay, back on track for step 2. We're going to look at the adjustment factors. There are more adjustment factors in the APA Simplified method, so it might seem a little more complicated, but it's to give the designer a little more freedom about the choices you can make. The first factor is common with the IRC Simplified method, wind exposure category. We're still going to choose B. Then we have a wall height of 9 feet. I know the slide says 9 foot 1 1/8 because that's what's often called out on drawings, but nominally it's a 9-foot stud. That adjustment factor is going to be 0.95. And then we are going to assume that interior gypsum is present and that the horizontal joints are blocked. So both of those adjustment factors are 1. We're going to keep those in the example because they are requirements in the IRC Simplified method. So we want to be able to have an apples to apples comparison between these two. You see here at the top, we've multiplied our 9.4 from step 1.5 by 1 and 0.95 and by 1. That's going to give us 9 feet. It actually gives us 8.93, but for simplicity, it's 9. We can start our layout again. Let's go left to right. We are still going to need that section next to the door to be a portal frame. So that counts as 1.5 times the length. So there's a 2-foot portal frame that counts as 3 feet of wall bracing. Similar to the IRC example, we're going to use the 3-foot panel next to the garage and the other 3-foot panel on the other side of the garage. Those both meet the minimum length requirements. We add up 3 plus 3 plus 3, which is 9. So we needed 9 feet, and we have exactly 9 feet. Awfully convenient how that math worked out. It's almost like I planned it. With this bracing, the wall would be in compliance. And in this situation, we would be able to utilize the APA Simplified method to make a configuration work that does not work for the IRC Simplified method. I do want to point out that we need to have the offset requirements from the front wall be less than 4 feet. If it was more than 4 feet, you wouldn't even be able to use this method, so it would not comply. The APA Simplified method is not going to work in every situation, nor is the IRC Simplified method. They have advantages and disadvantages, but they are useful tools to have in your tool belt. Just for giggles, we didn't talk about it today, but I looked at our example from the IRC traditional method. I'm not going to walk through how we got these numbers. We don't have time. I'm just going to tell you the results. If you would like to learn more about traditional IRC wall bracing, APA has several webinars that walk you through the process. We would have a portal frame next to this door, then the 2 3-foot panels next to the garage. These are the same bracing panels that we had in the simplified methods. The requirement is 10 feet, and we have 9 feet of bracing, so this method does not comply. The thicker performance category of the panels and the different nailing pattern gives the bracing panels a stronger resistance, which is why the APA Simplified method has a requirement of 9 feet, while the IRC traditional method is 10 feet. I do want to say that you can always modify your design. In this case, if we get rid of the side light next to the door and we have a 4-foot panel on the left side, it no longer needs to be a portal frame because it meets the minimum length. And then the math becomes 4 plus 3 plus 3, which is 10 feet. So that would comply. Another option would be to utilize the panels next to the garage as continuously sheathed portal frames. Let's walk through that scenario. We would keep the continuously sheathed portal frame next to the door and the side light, and then we would have 2 continuously sheathed portal frames, one on each side of the garage. Those portal frames would count as 4.5 feet of bracing each. This would add up to 12 feet of bracing, so that would also comply. What I want you to take away is that there are a variety of options for how to make your wall bracing work. It is up to you as the designer to choose the methods you want to use. If you ever have trouble comparing the methods, you can refer back to this webinar or reach out to APA. This is another summary page. It reviews the bracing on the first floor front wall of a standalone townhouse. The requirements are in the upper left corner. The minimum performance category for each of the methods is shown here. The APA Simplified method needs 7/16 inch performance category continuous sheathing around the entire perimeter, and the IRC methods require 3/8 inch minimum performance category sheathing. The perimeter nailing is 6D or 8D common nails for the IRC methods, and it changes based on the performance category of the sheathing selected. The APA Simplified method will always use 8D common nails, and the APA Simplified method has a nail spacing of 4 inches on center at the lower stories, while the IRC Simplified method has a nail spacing of 6 inches on center. In all the methods, the nailing at the intermediate supports is spaced at 12 inches on center. As mentioned above, the nail size can vary in the IRC methods based on the performance category of the sheathing. Our conclusions were that the wall bracing in the APA Simplified method complies, the bracing will not work for the IRC Simplified method, and the IRC traditional method could comply if we removed the side light next to the door or used more portal frames next to the garage. That is all we have for today. So with that, I can turn it back over to Pat and we can answer some questions.
Jacqueline, time for a few questions. Here's the first. Have there been changes to the IRC Simplified method in different code editions?
Yes, that's a great question. So the International Residential Code, obviously updates with every cycle. I would say the biggest change for simplified method comes between the 2012 and the 2015 IRC. That code edition went from service design wind speed to ultimate design wind speed. That was a code-wide change, but obviously that affects the simplified wall bracing as well. There are other minor changes. We talked about some of them in this presentation. In 2021 and 2024 IRC, they removed the limitation that you can only have 4 continuously sheathed portal frames in one wall line. But overall, the main steps that we talked through, the circumscribing the rectangle, the adjustment factors, those are consistent through all of the different code editions. So make sure you check what code is adopted in your local area and you use the correct code, but overall, a lot of those steps are going to be the same through the different code editions.
Next question. Can you use the IRC and APA Simplified method on certain walls or stories without using it on the whole structure?
No, the APA and the IRC Simplified method are an all or nothing. So you use the entire structure, all the stories, all the walls, or you don't use it at all. There's no way to kind of break it up and have just one wall be an engineered design. If you're going to go that route, you have to use either the IRC traditional method or engineered design.
Okay. And the last question we have time for. The conventional non-simplified IRC wall bracing method provides reduced braced wall panel lengths for wind speeds down to less than 110 and 90 miles per hour. Is this an option for the simplified methods?
Unfortunately, it's not. Because they are simplified methods, they kind of had to reduce the amount of content in there. So they only use wind speeds of 115 miles per hour and 130 miles per hour. If we start to add in more wind speeds, more adjustment factors, at that point, it just kind of becomes the IRC traditional method. So that's just one of the limitations of using the simplified method. We talked about that through this webinar, that there are trade-offs. And that's just one of the trade-offs. So potentially, if you are in a wind design speed of 95 miles per hour or something like that, it could be a lower wall bracing requirement to use the traditional method than the simplified method. But that's just one of the downsides of the simplified methods.
All right, thank you, Jacqueline. Regarding reference publications, you can use your smartphone camera and a link will take you to the APA webpage to download the respective publication. These are included in the handout for your use. As I mentioned, APA has field staff located throughout North America. your local APA Engineered Wood Specialist is a free resource that is available to you for assistance or for any questions you may have regarding APA Engineered Wood products. Their individual contact information can be found on the staff contacts page of the APA website. To navigate to this page, you can go to apawood.org, select contacts at the top. This will take you to our main contacts page. If you select the Learn More option under Market Access and Development, you will navigate to our Engineered Wood Specialist page with a map showing the different territories where we have field staff. By scrolling down, you can select the appropriate region and get contact information for your local Engineered Wood Specialist. And finally, make sure that you are signed up to receive our APA update newsletter so that you will be notified of our future webinars and updates to APA publications and standards. To receive it, all you need to do, starting from the homepage of our website, is to click on Sign In the upper right-hand corner of the page. In the menu that drops down, simply select Register. From there, you will need to let us know what you'd specifically like to receive, which in this case is the APA update newsletter. Additionally, APA has resources to assist you at our help desk that can be reached through email at help@apawood.org or by phone. Thank you for attending.